Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 2 on the chapter of playing with numbers for 10 good problems, where this video is part of the series of videos of 10 good problems where I solve 10 problems of HOT, that is high order thinking, for a particular chapter. Uh, so this video I will solve. This is set 2 of 10 good problems from the chapter of playing with numbers. If you want to, if you have not watched the set 1 video where I solved the first set of 10 good problems, I strongly request and suggest that you watch that video as well. And also, if you have not watched my theoretical videos from the playlist CBSE Maths 8 RS Agarwal, where I discuss the theoretical aspect of the chapters following the textbook of RS Agarwal, then you can also watch those videos. So this video is part of the playlist Maths 8 HOT. HOT stands for High Order Thinking Problems. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future video. So let's start solving the set 2 of 10 good problems from the chapter of playing with numbers. Okay, so I have the 10 good problems question paper on the left hand side. It is always recommended that you try to solve the problems yourself first, and only if you are stuck and if you cannot solve the problems after multiple attempts, then you see this video for my solution as a reference. Now, it is highly possible that I will be stuck at solving any problem or I won't be able to solve any problem at all. So that can happen. Uh, so please be prepared that for maybe for one or two problems I won't be able to provide any solution. But the more important thing is that uh, uh, the more important aspect of making this video is that to provide you with a good set of 10 with a set of 10 good problems which if you practice and solve, it will give you a good evaluation of your understanding of the chapter concepts. Okay, so after solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will be beneficial to you. Okay, let me quickly check if everything is visible or not. I hope the fonts of the question paper are big enough and you can read it properly. The question paper PDF link will be in the description below, so you can check the PDF from the description. Okay. So let's start solving the problems. The first problem says that a four-digit number AB, where AB are digits, is divisible by. Okay, so the number given is AB and AB. That is a two-digit number. AB is repeated twice, and it is we have to check whatever irrespective of the digits, whatever the digits A and B are, by which number this number will be divisible. That is, we have to check whether it is divisible by 100 or 11 or 100, 1001 or 101. Now, definitely, the digit A cannot be 0 because a number cannot start with the digit A. Okay, so using the general form of numbers, we can say this is equal to this is a four-digit number. So this will be, if we expand it in the general form, this will be 1000 A plus then it will be 100 B and then it will be 10 A and then it will be B. Okay. Now this is, if we simplify, add up the A terms and add up the B terms, we get this is 1010 A 1010A plus 101B. Now this is equal to 101 multiplied by 10a plus 101 multiplied by b. Okay. Now we can take 101 common and we get 101 multiplied by 10a plus b. So clearly we can see this is divisible. This is divisible by 101. Now we are not sure about what the value will be 10a plus b, but we are sure that this number AB irrespective of whatever the digits a and b are, definitely a will not be 0. It will be this number in this format, that is AB is divisible by 101. So I think the correct choice will be D. The correct choice is D, because we don't know what will be the value of A and B. So we cannot say whether it will be, this number will be divisible by 100 or 1001 or even 11. But we can say for sure that this number will be divisible by 101. Okay, let's solve problem number 2. Okay, so it is given a 3-digit number 8x3 is equal to 100 into 8 plus 10 into 5 plus 1 into y. Then what is the value of x minus y? So this equation is given. Now where the left hand side is a 3-digit number and on the right hand side is a expanded form, there is a general form of a number. Now if we generalize, if we apply the general form of number to the left hand side 3-digit number, we get the left hand side becomes, it is a 3-digit number, so this will be 100 multiplied by a plus 10 multiplied by x plus 1 multiplied by 3. This is equal to, given on the right hand side, 100 multiplied by 8 plus 10 multiplied by 5 plus 1 multiplied by y. Now if you compare the factors of 100, 10 and 1 on the left hand side and the right hand side, compare the factors of 100, 10 and 1 on the left hand side and the right hand side, we will get definitely that 8 is equal to 8, that is fine. But if so we need not compare the factor of 100, but if we compare the factor of 10 and 1 on the left hand side and the right hand side, we get x is equal to 5 and y is equal to 3. So this implies we have to find the value of x minus y. So this is equal to 5 minus 3, which is 2. Which is 2. So the correct choice is A. Okay, let's do problem number 3. Problem number 3 says, if the product of x and y and 5 is zxy, then the value of z minus y is. So it is given a kind of x and y is a 2-digit number, and if you multiply with 5, the result is z, x and y. Now, so from this multiplication result, we can see that y multiplied by 5 units digit of, we can see that we can see that when we do the multiplication from column 1 multiplication, we see that y multiplied by 5 is equal to y. Now When can this be? When can what possibly can the value of y be such that y multiplied by 5 is equal to y? Uh, so if y is 5, if y is 5, we can see that uh, 5 into 5 is 25 and the units digit of 25 is 5. So 5 y is equal to 5 is a possibility. For y multiplied by 5 to give the unit digit of y multiplied by 5 is y. In this case, the possible value of y is equal to 5. So we can say that y, one possible value is 5. Is there any other number, any other digit of y when multiplied by 5, the unit digit will also be y. It cannot be 3 because 3 multiplied by 15 is 5. Can it be 4? No. Can it be 6? No. Can it be 7, 8? Because anything multiplied by 5 is either 0 or I guess is 5. 0 or 5. Now, okay, so 0 or 5. So if y is 0, then 0 multiplied by 5 is 0. So the 0 is also a possibility. So in this case, y can be 0 or 5. Okay. Now, xy multiplied by 5. Okay. Now, the possible value of y is 0 or 5. Now, if let's see what happens if y is equals to 0. If y is 0, we get x 0 when multiplied by 5 gives z, x is 0, so 0, no, not x, but y is 0. So we get x and 0. If we consider the y is equals to 0, we get this. Now, what can x and z be? If so, this result, from this result we can say a possible value of x can be 5. A possible value of x can be 5 because then 50, if x is 5, then 50 multiplied by 5 is 250. 250 and z will be equals to 2. So this is one possibility. What else can the value of x be such that x0 multiplied by 5 gives zx0? It cannot be 0. So the only two, so if a digit, so we see that if a digit a gets multiplied by 5 and it gives the digit a only, then this will imply, this is a side note, this will imply that a can only be 0 or 5. So in this case, when x0 is multiplied by 5, we are getting as a result zx0. So if x, so we can see that x multiplied by x, so x multiplied by 5 should give zx. So what can the value of x be? If x is 5, can x be so x can be 5. If x is 5, then we are getting 50 multiplied by 5 is 250, and in that case z can be 2. So y, we can see y equals to 0, x equals to 5 and z equals to 2 is a possible solution. Solution, and we can see that we have been asked to find the value of z minus y. So in this case, z minus y will be 2 minus 0 equals to 2. But we have only considered the y equals to 0 as a possible value, because we can see that from column 1 computation, y can have value of the value of y can be 0 or 5. When we considered y equals to 0, we found that x can be 5 and z is 2. Now if y is 0, can x can have any other value? If y is 0, x because we also see that x multiplied by 5, it gives x as the unit digit. When x is multiplied by 5, the unit digit, the result of the unit digit is x. So in that case, x has to be either 0 or 5, and x cannot be 0. Definitely x has to be 5. Okay. Now let's see what if we consider y as 5. If y is 5, then this becomes, the multiplication becomes x5 when multiplied by 5 gives z x and 5. Okay. Now if y is 5, then oh no, one second. Okay, if y is 5, okay, so if y is 5, then we are having the result x5 multiplied by 5 is zx5. Now 5, so obviously 5 multiplied by 5 is 25. So we will have carry over 2. We will have a carry forward 2. Now what can the value of x be, such that x multiplied by 5 plus 2 will give as the units at the digit at the units digit at the result as x only. Can there be any value of x as a digit such that x multiplied, the digit x multiplied by 5 added to 2 will give the result, the unit digit of the result will be x only. 6, no. If can x be 2? Can x be 2? If x is 2, then 2 multiplied by 5 is 10, and 10 plus 2 is 2. Okay, so x can be 2. One possibility is that x can be 2. X can be 2. In that case, if x is 2, we are getting 25 multiplied by 5 is 125, and z has to be equals to 1. So in this case, this is also a possible solution, that is y is equal to 5, x is equal to 2, and z is equal to 1. Z is equal to 1. So when 25 multiplied by 5, it gives 125. So in this case, we can see for the previous solution, y equals to 0, x equals to 5, z equals to 2, we can see we have to find the value of z minus y. So in this case, z minus y is equal to 2 minus 0, which is equal to 2. So one possible value of z minus y is 2. Now if we consider y is equal to 5, x equals to 2, and z equals to 1, this is also a possible solution. And so in this for this solution, we see that z minus y is equal to 1 minus 5 equals to minus 4, but minus 4 is not in the option. Now, okay, Now with y is equal to 5, can x have any other value other than 2 such that x5 multiplied by 5 is zx5. Can x be 3, 2, no, it cannot be 3. Can x be 4? Uh, can x be 4? Uh, no, x cannot be 4. Can x be 5? Can x be 5? Then 55 multiplied by 5 is 275. No. Can x be 8? 85 multiplied by 5 is 542. No. So for if y is equal to 5, the only solution we are getting is x equals to 2, and in that case z equals to 1. So for this solution, z minus y is minus 4, and minus 4 is not the option. So the only solution that is the only solution where the z minus y is matching with the given choice is z minus y equals to 2. Z minus y is equal to 2. So the correct choice is A. A is the correct choice. Okay, let's do problem number 4. Again, the missing digits, we have to fill up the values of the missing digits with numerals. It is a multiplication again. A, 5A when multiplied with the digit A gives the result as 1B, 5 and 9. We can see for the computation of column 1 that units digit of digit A multiplied by digit A is equal to 9. So what can possibly the digit A be such that the units digit of A into A is equal to 9? One possibly is 3. A can be 3. A can be 3. What else value can A have? If A can be 7, A can also be 7, because 7 is 49 and the units digit of 49 is 9. So these are the two possible values of A and B, such that A multiplied by A, the units digit of the result is 9. Okay, so let's see what happens the scenario when A is equal to 3. So we have 353 multiplied by 3, and let's see what it gives. It gives 9, 15 and 1059. So 1059, and we can clearly see it matches exactly with the given result, that is 1B59. 1B59. So we can say that this result implies that one solution can be x A equals to 3 and B is equal to 0, B equals to 0. Now if we consider A equals to 7, then what we get as a result, we have 757 multiplied by 7, and this becomes 49, 35, 39, 49, 52. No, this cannot be the case. A cannot be 7 because the result is having 5000 something, but in the given result the result is 1000 something. So this implies that A is not equals to 7. So the answer is A equals to 3 and B equals to 0. So this implies we have to find the value of A and B. Okay, so this implies the answer is A is 3 and B is 0. So answer is choice B. Okay, let's do problem number 5. It is given that the number 5, 5, 4, 2, 3 m is divisible by 18. How many possible values can m hold? So in the given, it is a 6-digit number 55423m. The digit at the units place is m, which is unknown, and this whole number is given to be divisible by 18. Then we have to find how many values of m can be, how many values m can hold. Now divisible by 9 by 18, we do not know any rule, divisibility rule of 18. So we have to factorize the number 18 into factors such that no two factors have a common factor. So the factor of, we can factorize 18 as 6 into 3, but we will not consider this because 6 and 3 has a common factor of 3. Another factorization of 18 is 9 into 2. We will consider this because 9 and 2 do not have a common factor. So after we factorize, it must be the case that the given number must be divisible by all the factors. So this implies that 5, 4, 2, 3 m must be divisible by 9 and 2. 9 and 2. Okay. Now this implies that if a number has to be divisible by 2, that number has to be even, which means the digit at the units place must be even. So this implies m is even. The digit m has to be even. So we got this in result from the fact that the whole number must be divisible by 2, and all even numbers are divisible by 2, and the even number has the units digit even. Now since the number is also has to be divisible by 9, from that we get that the sum of the digits must also be divisible by 9. So we must have 5 plus 5 plus 4 plus 2 plus 3 plus m are divisible by 9. So this implies 10 plus 14, 16. This implies 19 plus m is divisible by 9. Now what is the next now? So what can the values of the digit m be such that 19 plus m is divisible by 9? So after 19, the next number that is divisible by 9 is 21, and for 19 plus m to be 21, m must be 2. So the least value of m such that 19 plus m is divisible by 9 is 2. So what is the next value of m that will make 19 plus 9 divisible by 9? The next number after 21, which is divisible by 9 is sorry my mistake. The next number after 19 which is divisible by 9 is 27, and so what will be the value of m such that 19 plus m is 27? It is 8. So the least value of m such that 19 plus m is divisible by 9 is 8, because 19 plus 8 is 27, which is the next number after 19 which is divisible by 9. Now after 27, what is the number which is divisible by 9? That is 36. Now for 36, 19 plus m to be 36, the value of m has to be such a number which is greater than 9, but m cannot be greater than 9 because m is a digit whose values will be from 0 to 9. So the only possible value of m is 8. The only possible value of m is 8. So what is the number of possible values of m can hold is 1. How many possible values can m hold? How many possible values can n hold? Okay, so we are having only one possible value of m, which is 8. So this implies the answer is choice A. So the only value of m such that the given number 55423m is divisible by 18 is 8. Okay, let's do problem number 6. Let ABC be a 3-digit number, then the value of ABC minus CBA is not divisible by. So ABC is a number, and we have to see, we have to find the value of ABC minus CBA. Now, if we expand the given numbers in the general form, we get ABC minus CBA will be equal to the general form of the number ABC is a 3-digit number, so it will be 100A plus 10B plus C, and the general form of the number CBA will be 100C plus 10B plus A. So if we open the brackets and we combine the similar terms, we get 100A minus A, plus we get 10B minus 10B, and we get C minus 100C. So this is equal to 99A. 10B gets cancelled out, and we get minus 99C. This is equal to, we can take out 99 as common, and we get 99 multiplied by A minus C. Okay, now 99 can be written as 9 multiplied by 11 multiplied by A minus C. Now 9 can also be written as, okay, so this is 9 into 11 into A minus C. So this number, that is the value ABC minus CBA, which is equal to 9 into 11 into A minus C, this is divisible. This is divisible. This is divisible by 9, this is divisible by 3, and this is also divisible by A minus C. We have to choose the choice where the value of ABC minus CBA is not divisible by. Now, sorry, so the 9 into 11, okay. So 9 into 11 can further be factorized as 3 into 3 into 11, and then we have into A minus C. So this means that it is divisible. It is divisible by 3. This is also divisible by 3 into 3, that is 9. This is also divisible by 3 into 11, that is 33. And of course, this is divisible by 99, and also this is divisible by 11. So we have to see. So these are the numbers. These are the numbers by which the number will be divisible, and we have to select the choice which does not have which does not belong to these numbers. So the choices are 9, 11, 18 and 33. So obviously the given number is not divisible by 18. So the correct choice is C. C is the correct choice. Okay, let's do problem number 7. It says that if the equation is given 4A 8 plus 364 is equal to 7B 2. It is given that this number 7B 2, which is equal to 4A 8 plus 364, this number is divisible by 9. Okay, so divisible divisible by 9. So this implies that the number 7b2, the number 7b2 is divisible by 9. Now we know that a number is divisible by 9 when the sum of its digits is divisible by 9. So we must have 7 plus b plus 2 is divisible by 9. So this means 9 plus b is divisible by 9. So this implies what can the possible value of b be such that 9 plus b is divisible by 9. So the possible b can be equal to 0 and b can also be equal to 9. We have to find the value of b minus a. So b can be 0, b can also be 9. So these are the only two possibilities of b. B can be 0 or 9. Now, if b is equal to 0, if b is equal to we have to, since there is only one it has asked the value of b minus a and all the choices are single valued. This means that there will be only one value of b minus a, which means that there will be only one value of b and a. Okay. Now, up to this we can see that we see that 9 plus b must be divisible by 9. So this means b can have the value 0 or 9. Now, if b is equal to 0, if b equals to 0, we get 4a 8 plus 364 is equal to 702. So this implies 4a8 is equal to 702 minus 364, which is equal to 8, which is equal to 338. 702 minus 364 is equal to 338. Now, this cannot be the case. 4a8 cannot be equal to 338 because the leftmost digit is not matching. So this implies that b is not equal to 0. b equal to 0 cannot be a solution. So this implies b is equal to 9. So this implies 4a8 plus 364 is equal to 792. So this implies 4a8 is equal to 792 minus 364, which is equal to 8, 12, 7, 2 and 4. So now we can see that this implies if 4a8 is equal to 428, this implies a is equal to 2. This implies, so we have the solution a equals to 2 and b equals to 9. This implies a, we have to find the value of b minus a. So b minus a is equal to 9 minus 2, which is equal to 7. So the correct choice is C. C is the correct choice. Okay, let's do problem number 8. Problem number 8. Okay, problem number 8 says it is given that the 4-digit number 76K9 plus the 4-digit number 6K79. This number is divisible by 3. Is divisible by 3. Then the sum of least and greatest value of k. We have to find the least and greatest value of k such that the sum of the two numbers 76K9 and 6K79 is a multiple, is divisible by 3. Okay, now mm, is divisible by 3. Now, so we now 76K9 plus 6K79. If we expand the numbers as the general form, we get this as 767. We know that 76K9 is equal to 7600 plus K9, and we also have 6K700 as 6K79. The number 6K79 will be equal to 6K into 100 plus 79. This is equal to 7679 plus K9 is 10K plus 9, and we have 6K into 100. So this is equal to this is equal to 7679 plus 9 is 7688, and we have 10K plus 10K plus 600K. Now for this number to be divisible by 3, what can the possible value of K be? The sum of, we have to ask, the question is to find the least and greatest value of K. Now is 7688, this is, if this is divisible by 3 or not, we have to check that first. So 7 plus 6 plus 8 plus 8 is equal to 13 and 21 and 29. So this 7688 is not divisible by 3. Uh, Now I think I am solving it in a wrong way, wrong approach. I think the number is given, it is a sum of two numbers, sum of two 4-digit numbers, 76K9 and 6K79. So if sum of two numbers, it has to be divisible by 3. Then 2 plus 4, 6, okay, is divisible by 3. Uh, So 6K9 plus 2 by 3. So we have this. So we have expressed the sum of the given two numbers uh, using the general form of each number, individual number. We have expressed the sum as 7688 plus 10k plus 600k. Now, this is equal to 7688 plus 610k is equal to 610k. Mm, 610k. Uh, Now, oh, 6. Let me check quickly once again if I did the expansion of the numbers in general form correctly or not. So 76k9 plus 6k79. 76k9 is equal to 7600 plus k9. Okay, and plus we have uh, mm, uh, so let me do it once again. So we have this is equal to 7000. If we expand it using the general form, we have 7 multiplied by 1000 plus 6 multiplied by 100 plus 10 multiplied by k plus 9, and plus we have for the second number we have 6 multiplied by 1000 plus 100 multiplied by k plus 10 multiplied by 7 plus 9. Now if we simplify, we get further 7000 plus 600 plus 10k plus 9 plus 6000 plus 100k plus 70 plus 9. This is equal to, after further simplification, it will be 7000 plus 6000 is 13,000. 13 13,000 plus 600 plus 9, 600 plus 70 is 670, and 9 plus 9 is 18, and we have 100k plus 10k, that is 110k. This is equal to this is equal to uh, 8 and then 8 and then 6, 13688 plus 110k. So 13,688 plus 110k must be divisible by 3. Now 13,688 is not divisible by 3. 13,000 when we now k is a digit, so its value definitely will be from 0 to 9. 0 to 9. And when we divide the number 13,000 13,688, we get 4, 12, 1, 6, 5, 15, 1, 8, 6, 18 and 8. So when we divide 13,688 by 3, we get the quotient as 4,560 and the remainder as what 14, 12, 4, 1, 16, 5, 15, 1, 8, 6, 18, 0, 8, and then we have 3, 2, 6. So when we divide 13,688 by 3, the quotient is 4562 and the remainder is 2. The remainder is 2. So what can the value of k be such that 13,688 plus 110k will be divisible by 3? So the next number, since k is a digit from whose value is from 0 to 9, 110k will always be positive. That is, it can be 0 or greater than 0. So the next number after 13,689, which is divisible by 3, will be 4, 5, 6, 3 multiplied by 3, which is equal to 9, 6, 18, 16, 13689. Okay, 13689. So we must, if we okay. The next number after 13,688, which is divisible by 3, will be 13,689. So if somehow 110k is 1, then the whole number can be divisible by 3, but 110k cannot be equal to 1. Now so what is the next number after 13,689, which is divisible by 3? That will be 4, 5, 6, 4, 5, 6, 4. multiplied by 3, which is equal to 12, 19, 13692. 13692. Now, so 13688 plus 4. So in that case, 110k has to be 4, which cannot be the case, because um, three 0. Then the sum of least and greatest value of k is it is 2 and 110k. Now the remainder, when the number 13,688 when divided by 3, it leaves a remainder 2. So the 110k must leave a remainder 1, so that the whole number will be divisible by 3. Now if k is equal to 1, then 110, if k is equal to 1, if k is equal to 1, implies 100 and 10k is equal to 110. And when 110 is divided by 3, it leaves a remainder. When 110 is divided by 3, it leaves a remainder 2. It leaves a remainder 2. It leaves a remainder 2. No, I think I don't know. Maybe I'm not. My approach is not correct. I will skip this question as of now. I will come back. So this is a question mark. I will come back to this question later on. So let's do problem number 9. It says that the given, it's a kind of puzzle. We have to fill in the missing digits. So it is given that 68a plus 6a5 is equal to 1340. So this is the addition of two 3-digit number. So from the column 1 addition, we see that the units digit of a plus 5 is equal to 0. So this implies that a has to be equal to 5. The only choice of a such that a plus 5 is equal to 0 is a equals to 5. Now if a is equal to 5, this implies 6, 8, 5 and 6, 5, 5. If we add, what is the result? We have 10 and 9 and 14 and 12 and 13, which is exactly matching with the result. So this implies a equals to 5 is the value of a, and so the correct choice is D. D is the correct choice. Okay, now let's do problem number 10. It is also an addition of, addition of 3-digit number PQR plus PQR. PQR plus PQR, the result is SR8Q. SR8Q. Uh, this kind of problem really puts me in trouble. I'm not always able to solve it properly. Now, the question is, do we apply the general form of numbers? So, if we say that the result is something like PQR plus PQR is equal to SR8Q. Okay. Now, so this implies if we expand the left hand side numbers in the general form and the right hand side number in the general form, we get PQR. So we have 100P plus 10Q plus R. And for also, so this is same 100P plus 10Q plus R. On the right hand side, we have it is a 4-digit number. So this will be 1000 S plus 100 R plus 10 into 8 plus Q. So this implies we have 2 times we have 200 P plus 20 Q plus 2R is equal to 1000 S plus 100 R plus 80 plus Q plus Q. What does this mean? Now 20Q. Now PQ are digits, their values lie from 0 to 9. So definitely R 80 plus Q twice R. Hundred. So P equals to 10s equals to 5s 5s. Yes. Hundred R plus 80 4. Now Q equals to 4. 4 twice R. R equals to 7. No. No, I am not really not getting any. This step is not leading to any useful information. Why is R equals to Q? Nine 180. Now, if I do the column wise column addition, we can see that column 1 addition, it is see that units digit units digit of 2r plus r is 2r, 2r is equal to q. The units digit of r plus r, that is 2r, is equal to q. So this can imply that r plus r is either equal to q or it can be 1q. This implies twice r is equal to q or 1q. Twice r is equal to q. R plus r is equal to q. Q or 1q. So we get, let's for the time being, I'm removing this part. Let's try to solve this problem by doing column wise addition. So for the column 1 addition, we see that r plus r, the units digit of r plus r is q. That is, the units digit of twice r is equal to q, which means that r plus r can be q or r plus r can be 1q. Now, if let's say, so we are having two possibilities, either twice r is equal to q or twice r is equal to 1q. So if twice r is equal to q, what do we get? If twice r is equal to q, then what can twice r? Now, so for the column 2 addition, we see that units digit of q plus q is given to be 8. So this implies that when twice r is equal to q, this means that there is no carry forward from the column 1. So this will imply twice q is equal to 8 or 18. Twice q is equal to 8 or 18. 9. 3, 3, 9. Okay, so we are getting twice q is equal to 8 or 18. This implies q is equal to 4 or 9. Q is equal to 4 or 9. But we do not see 9 in any of the given choices. So q cannot be, we should ignore the value of q as 9. Okay. So 9 is not in choice. Not in choice. In none of the choices, we see value of 9. So if we consider twice r equals to q, then we are getting q is equal to 4. q is equal to 4. And so if q is equal to 4, then r will be equal to 2. If this implies q equals to 4, so this implies r, we know that r is twice r is equal to q. So r will be equal to 4 by 2, that is equal to 2. So r is 2. Okay. Now again, if twice r equals to q, for the in column 2 addition, we see that q is equal to 4. Q is equal to 4. So there will be no carry forward. So let's see what will be the addition of for column 3. We have units digit of p plus p is equal to r is equal to r, which is equal to r we have already found to be 2. The units digit of p plus p is equal to 2. So this implies p plus p can be equal to 2 or 12. P plus p equals to 2. Now p plus p cannot be 2. P plus p cannot be 2 because we see there is a there is a carry forward. That is why we see the digit s. If p plus p equals to 2 and there is no carry forward from column 2, then the digit s would not exist. Okay, so this implies that p plus p has to be equal to 12. So this implies p is equal to 12 by 2, which is equal to 6. So we see okay, if p is equal to 6, this implies that 6 plus 6 is equal to 12. So this implies s must be equal to 1. So one solution is that from the very first result that twice r is equal to q or 1q, if we consider twice r equals to q, from that assumption twice r equals to q, we get the solution as p is equal to 6, q is equal to 4, and r is equal to 2, and s is equal to 1, from the assumption that twice r equals to q. Now we have to also consider the assumption, we have to also consider the possibility that twice r is equal to 1q. Now when we have found from the fact that twice r equals to q, we have found the solution p equals to, we have found the solution 6421, and we can clearly see 6421 as a solution in the given choice, which is choice A. So we can clearly say that the right choice is A. Now back to the question which I could not solve was this problem, which is problem number 8. Let me give another try if I can solve the problem number 8. So the given number is the sum of two numbers, and each number is a 4-digit number. The first is 76k9 plus 6k79. This number has to be divisible by 3. Now the sum of two numbers, it is not the case that if we have a plus b are divisible by 3, it is not the case that individually a will also be divisible by 3 and b will also be divisible by 3. It may not be the case, because a could be 2, b could be 4, and 2 plus 4, 6 is divisible by 3, but none of 2 and 4 are divisible by 3. Then the sum of the least and greatest value of k is, okay. Now one way is that you can do a trial and error method. Since the possible values of k can be 0 to 9, you can try out all the possible values, that is 0, k equals to 0, k equals to 1, and check whether this given number will be divisible by 3 or 9. Even though this is a very bad approach, let's anyway use that, because I am not able to think of any better approach. So for k is equal to 0, we see the result value becomes 7609 plus 6079, which is equal to 18 and 8 and 1 3 6. For k equals to 0, we get uh, the result of the two numbers is 18 and then 8 and then 18, 8, 6 and 13, and the number 13,688 is not divisible by 3, because for k equals to 0, and we see the sum of the digits 136 plus 8 plus 8 is equal to 10, 18, 26, 26, which is not divisible by 3. So k equals to 0 is not for k equals to 0, whatever the result we are having after adding the two terms, it is not divisible by 3. This will be a lengthy process and definitely is not the correct approach, but I cannot think of any other better approach. So let's say for k equals to 1, the result becomes 7619 plus 6179, which is equal to 18, 9 and 7 and 13. Now what is 1 plus 3 plus 7 plus 9 plus 8 is equal to 10, 11, 20, 28. So this is also not divisible by 3. Not divisible by 3. Okay. For no, I do not think this way should be the approach. That trying out for all the possible values of k, we have to find the sum, the result, and then we have to see whether that result is divisible by 3 or not by adding the sum of the digits, by finding the sum of the digits. This will be a very lengthy process. We cannot check it for k equals to 0, k equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be a long process. There must be some shorter way of finding all the possible values of k for which this number should be divisible by 3. The expansion, when we expanded the two numbers, the expansion, let me see if the expansion can help. So we are getting 13688 plus 110k. What can the possible values of k be such that this number 13688 plus 110k will be divisible by 3? 2. 4, 1, 2. Okay, I can see that if I consider k equals to 2, mm, if k equals to 2, k equals to 1 was not working because if k equals to 1, 110k is equals to 110, and if we divide 110 by 3, we are getting a remainder of 2, and also if we divide 136,688 by 3, the remainder is 2. So a remainder of 2 plus 2 is 4. So that 4 is not divisible by 3. We have to consider a value of k such that 110k when divided by 3 will have a remainder of 1. Will have a remainder of 1. That is the catch. So uh, since 13688 when divided by 3 leaves a remainder, so uh, this when divided by 3 leaves remainder 2. So this implies 110k when divided by 3 should leave remainder 1. Only then 2 plus 1, the remainder from first number, that is when 13688 divided by 3 leaves the remainder 2, and if 110k when divided by 3 leaves the remainder 1, then 2 plus 1 get added and it will be completely exactly divisible by 3. So we must choose the value of k such that 110k must leave remainder 1 when divided by 3. So for we can see for k equals to 2, for k equals to 2, we see 100 and 110k is equal to 110 into 2, which is equal to 220, and we can see that 220 when divided by 3 will leaves a remainder uh, no 21. So when 220 divided by 3 leaves a remainder uh, leaves a remainder 1. So k for k equals to 2, we must have, since k equals to 2, 110 into k, that is 110 into 2 is leaving a remainder of 1 when divided by 3, and this remainder 1 and the remainder 2 from the 13688 division by 3 will make the sum exactly divisible by 3. So 1 k equals to 1 is the least number, k equals to 2 is the least number of k such that the given sum of the numbers will be divisible by 3. Now for k equals to 3, 110 3n plus 1. So 110k when divided by 3 should leave a remainder 1. Uh, what can that mean? Uh, we can say that 110k, if when divided by 3 leaves a remainder 1, we can say that then 110k should be of the form 3n plus 1, where n is some natural number, So what can k be? So we can choose different values of n such that mm, so definitely k equals to 2 is the least value for which the number, given number, the sum of two terms will be divisible by 3. So in that case, if for k equals to 2, what is k? And definitely k is a digit. Uh, 3n plus 1. What about k equals to 3? 110k will be 330. 330. No, 330 is exactly divisible by 330 for k equals to 3. 110k into 3 is exactly divisible by 3. So it will not have a remainder of 1. So it will not work. So what about, so 200? Okay. So for k equals to 2, we are getting 100k, 110k is equal to 200, and 220, which will leave a remainder 1 when divided by 3. Okay. Uh, k equals to 3, 100, if k equals to 3, then 110k will be exactly divisible by 3. But we need some value of k such that 110k is when divided by 3 will leave a remainder of 1. So if k equals to 4, 110k will be 440, and for k equals to 4, 110k is equal to 110 into 4 equals to 440. Now 440 uh, uh, 440 when divided by 3, what is the remainder? The remainder is 1, 2. So k equals to 4 will not work. K equals to 4 will not work. So for k, so the let me solve it in a different area. So we must have this. Now the whole thing, now the whole problem has boiled down to the fact that 110k, we must find k such that we must find k such that 110k, what is this? Oh, okay. So 110k when divided by 3 should leave remainder 1. And so one such possible value of k was 2, because for k, when k equals to 2, 110k is equal to 220, which when divided by 3 leaves the remainder of 1. Now for, let's see, for k equals to 5, if k equals to 5, if k equals to 5, this implies that 110k is equal to 110 into 5, which is equal to 550. So what will be the remainder when 550 is divided by 3? when 550 is divided by 3, what is the remainder? 1, 3, 25, 8, 24, 1, 0, and 3 and 9 and 1. So the remainder is 1. So k equals to 5 is also a value. K equals to 5 is also a value. It has asked to find the sum of the least and greatest values of k. Okay. So k equals to 5 is a value. Possible solution. Now, can k equals to what if k equals to 6? K equals to 6, it will not work because 6 is a factor of 6 is a multiple of 3. So 110k, if k is equal to 6, 110k will be divisible by 3. So the next, as you can see, the first solution was for k equals to 2, and the second solution was when k equals to 5. So 2 plus 3 is equal to 5. So there is a possibility that the next solution could be 5 plus 3, that is 8. So let's see, if k equals to 8, if k is equal to 8, this implies 110k is equal to 880. Now let's see what is the remainder when 880 is divided by 3. We have 2, 6, 2, 8, 9, 27, 1, 0 and 3, 9 and 1. So we are having a remainder 1. So k equals to 8 is also a possible solution. Now beyond k, after 8, the possible value of k should be 8 plus 3, that is 11. But k is a digit, its value is from 0 to 9. So the possible values of k are 2, 5 and 8, and the difference between the sum of the least and the greatest value is 2 plus 8, which is equal to 10. So the correct choice is D. So this was a bit of a tricky question. The given two numbers, the sum of two terms, we expanded. The concept was to expand it using the general form of numbers, and we got the result, the sum of the two terms, as 13688 plus 110k. Now the concept is that this number should be divisible by 3. Now we see that the number 13688 when divided by 3 is leaving a remainder of 2. So for the whole number, that is 13688 plus 110k, to be divisible by 3, we must have 110k when divided by 3 should leave a remainder of 1. So that was the main concept. Now we have to find all the values of k such that the 110k when divided by 3 should leave a remainder of 1. We started with the value of k as 2, and we found that the least value of k such that the least value of k is 2, such that 110k is when divided by 3 is leaving a remainder of 1. So the next possible choice of value of k will be 2 plus 3, that is 5, and then the next possible solution of k such that 110k when divided by 3 leaves a remainder 1 should be 5 plus 3, that is 8, and then the next should be 8 plus 3, 11, but since k is a digit, it cannot have values greater than 9. So the possible values of k are 2, 5 and 8, and the least value of k is 2 and the largest value of k is 8. So their sum is 2 plus 8, that is 10. So this brings to an end in solving the problems, 10 good problems of set 2. I hope these problems will give you a good practice in evaluating your understanding of the concepts of playing with numbers. If this video was beneficial, then please like it, share it with your friends, and also please please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Very soon I will come up with another set, the set 3, of 10 good problems on this chapter, that is playing with numbers. And the idea is, as and when I am completing a chapter in the other playlist, that is CBSE Maths 8 RS Agarwal, I will upload a video in this playlist, that is Maths 8 HOT, on that chapter about 10 good problems. So thanks for watching, and until the next video, take care and bye.